Hey everybody, welcome to Cyber School, I guess. Should be pretty fun, should be weird, should be different. We'll kind of see how this all works. I'm trying to make this as close to me teaching you in the classroom as it can be. So our first lesson today, we're going to talk about relations. This does pick right back up where we left off. If you remember, we were learning about patterns and how to represent patterns with expressions. So you remember things like 4n minus 3. That could be used to represent a pattern of numbers. Now, what we're going to be really learning here is more so, if you remember patterns, there was input and output, right? You input a number and then it spits out something back at you. The relationship between that input-output is where we're heading, right? Think about that word I just said, the relationship. These are called relations. So really, we're going to start learning a lot more about how input and output interact with each other. But before we can even get into that, we got to go over this stuff. So, the basic definition, a relation is a set of ordered pairs, right? It's just a set of ordered pairs. What's an ordered pair? Well, if you remember, an ordered pair is just an x comma y, right? So anytime there's an x and a y, we have an ordered pair. So any set of these ordered pairs can be considered a relation, right? So what could that look like? Well, 2, 1. There's a relation. It's just one, right? It's just one ordered pair, but that's technically a relation. Basically, what are we saying here? 2 is related to 1. 2 is related to 1. That's what it means, right? X is 2, Y is 1. And, we could have more in here, right? We could have 2, 1, and we could have 3, 3, and maybe 2, 5. So 3 ordered pairs, right? 2 is related to 1, 3 is related to 3, 2 is also related to 5. Now you might notice 2 relates to 1 and 2 relates to 5. That's something we'll be talking about in a later lesson, because sometimes this will mess things up. Having the same number, the same input number related to a different output. For now, all you have to know is that this is what a relation looks like, right? It's just 3 points, 3 ordered pairs, right? Now, a relation can be represented in quite a few different ways. Clearly, here's one way to represent it. You just write them out, right? But if they are coordinates or ordered pairs, that means you can represent them with a graph, right? We could just plot these points on the graph. Or we could use something called a mapping diagram, which we'll talk about in a second. For now, how do you represent points, right? How do you represent ordered pairs on a graph? Well, 2, 1, isn't this x and this y? So find 2 on the x-axis and go up to 1 on the y-axis. That'll put us right there. 3, 3. Again, there's x, there's y. So find 3 on the x-axis, go up to 3 on the y-axis. 2, 5. Again, x, y. Find 2 on the x-axis, 5 on the y-axis. Here's 2 on the x, you go up to 5 on the y. So, that should be nothing new, right? We've plotted points before. Graphs, we're going to be seeing a lot more of in the future. So anyway, plotting points, you can represent this relation using this graph. Now, a mapping diagram is something you may or may not have seen before. It's a pretty simple concept, though. So you might notice the way I started it, you have one circle to represent x, one circle to represent y. So what you do is all the x numbers go in the circle for x, surprise, surprise. All the numbers for y go in the circle for y. So in this relation here, I have a 2 and a 3 and then another 2. Well, all I'm going to put in here is a 2 and a 3. The fact that the 2 shows up twice, I don't write it down twice. I just put 2 and 3. And then the y values, 1, 3, and 5, I will put in like so. So, first things first. The numbers, they go in order, right? 2 and then 3, 1, 3, and then 5. So right now you're just looking at a list, right? This is just a list of the x's and a list of the y's, which is something we'll talk about in a little bit. Anyway, the way it works, remember, it's a relation. 2 is related to 1. So what I do is I will take a line and go from 2 to 1. That visually shows you that the 2 and the 1 are related. 3 is related to 3. So I'm going to take the 3 and draw a line to the 3. So again, visually representing the fact that 3 is related to 3, just like you see here. And then the last one, 2 related to 5. So 2, I will draw a line going to 5. Again, 2 as an input value, right? Remember, input, output, right? Input is x, output is y. I have the same x value or the same input value related to both 1 and 5. So you have 2 lines, right? So literally all a mapping diagram does is it visually shows which numbers pair with other numbers, right? 3 pairs with 3, 2 pairs with 1, 2 pairs with 5. Simple enough, right? Again, this is your input, this is your output. So, hopefully that makes sense. This is a very basic concept, right? This, again, a lot of what we do in math is build a foundation, right? What we're doing with these relations is building a foundation that we can then use to talk about something later called functions. We're just trying to lay the groundwork right now. Pretty basic stuff. Now, there is some other things to talk about related to relations. And that is the concept of domain and range. So whenever you talk about a relation or a function, right, this concept here, domain and range, this is a heavy hitter. This is something that you're going to see a lot of in future math classes, especially Algebra 2, elementary functions. So this concept, which we're not going to spend too much time on in this particular class, I'm trying to lay the groundwork. I'm trying to get you to understand the basics of this concept. That way next year and the year after that, you're better prepared, right? So they're actually very simple. Concepts, at least. The domain of any relation is just the set of all the x values in that relation. And the range of a relation is the set of all y values in that relation. Domain, x values. Range, y values, right? I always remember it because when you have x, comma, y, you could think about domain, comma, range. Think about the alphabet, right? X comes before Y in the alphabet. D comes before R. It's just a simple thing to remember. It's just domain and range. You always say it like that. Domain and range. Domain and range. drxy, right? X comes before y, domain comes before range, regardless. So let's just make a random relation. Let's say I had 2, 3, and 4, 1, and 3, 2. Well, if I wanted the domain for this relation and the range, need a list of x values, right? This will be very similar to the way I did my mapping diagram, right? So my domain is supposed to be all of the x values. Well, I have a 2 and a 4 and a 3. What I'll do is I'll write them in order. So 2, 3, 4. There's my domain. Very, very simple. It's just a list of numbers. Usually we put them in braces, these little like squiggle lines. But that's what they look like. Now the range, the list of my y values. So 3, 1, and 2. So which one comes first? The 1, then the 2, then the 3. So my range is 1, 2, 3. Very basic. So again, domain, you're just listing out the numbers. Range, you're just listing out the numbers. What if you were looking at a graph? Let's do a different relation for this graph here. Let's say I had the points right here, 1, 2. Say 2, 2, 3, 2, 4, 2. It's kind of going up there. So anyway, if I wanted to get my domain and range from a graph, it's basically the same thing, except you're reading a graph instead of reading points. So my domain, what are the x values? If I look at the points, 1, 2, 3, 4. So literally, 1, 2, 3, and 4. Simple enough. If I were to write the points out, what would it be? 1, 2, 2, 2, 3, 2, 4, 2. 1, 2, 3, 4. That's all my x values. Now the range, if you think about it, every one of these points has the same y value, 2, right? 1, 2, 2, 2, 3, 2, 4, 2. My range, and this is possible, is literally just a number, 2. My range is one number, and that's okay. So you list them out, right? You list your domain, 1, 2, 3, 4. You list your range, 2. That's it. One more time, let's do it with a mapping diagram. Let's make up another one like 3, 5, 6. Let's just go 1, 2, 3 here. So you see, 3 goes to 2, 5 goes to 1, 6 goes to 3. So if I wanted my domain, I mean, this is actually like too easy. Because remember I said when you're looking at a mapping diagram, you're kind of looking at the domain and range. This is the list of x values, right? 3, 5, and 6. And then your range, same thing. Isn't this your list of y values? So, 1, 2, 3. So asking you for the domain and range of a mapping diagram is actually like too easy. Might not even get that kind of question because a mapping diagram already shows you the domain and range. The hardest is going to be coming from graphs, and we're actually going to see a lot more difficult looking graphs than just this. For now, we're going to keep it easy. Starting next week, however, the graphs are going to intensify. That's pretty much it. That's all you need to know for now related to relations and domain and range. And this is something that I will be doing throughout every one of my lessons, but there's a number of the day, right? This is going to relate to your participation. The number of the day, 17. I'll post what to do about that on Google Classroom, but the number of the day is 17. Have a good day, people. Bye.